Okay, everybody, it's 7 o'clock. We're going to begin our webinar. And first of all, welcome to our webinar this evening. Today's topic is a review of the June 6th, 2020 severe thunderstorms here in southern New England. And as a reminder, everyone is on mute. It helps avoid background noise. So if you have a question, please use the chat box and we'll answer as many questions as we can at the end. As with all of our webinars, this is being recorded and we'll have it posted on our YouTube video page within a day or two, so you can look for this video there. And we have more webinars scheduled, so keep bookmark our page on our website, which is usually headlined up at the top, our event review, or I'm sorry, our webinar page, and also on social media, Facebook and Twitter. So we have a couple of webinars coming up. Next Tuesday, June 23rd, is Weather 101. This is kind of a introductory course to weather, climate, all things meteorology, but on more of a basic level. It doesn't get too technical, so we think a lot of you will enjoy it. And later down the road, we will plan what's called Weather 202, which goes into a little bit more depth to the meteorology, a little more technical, but we'll keep it as simple as we can. Then on that should be Thursday, July 2nd, we're going to have a webinar on marine forecasting, which means the winds and the waves. So for boaters, this is for you. We're going to cover topics related to boating, winds and waves, also talk about things like hurricanes and coastal storms and some general forecasting rules of thumb for our area. Also a Severe Weather 101 presentation we're working on. We're finishing that up. That's coming soon. Should be by the middle of July. We'll be scheduling that. And that's kind of a basic look at some of the ingredients we look at for severe weather. You'll see some of the things tonight, but it'll be a more in-depth review of severe weather. Also, we're planning tropical weather, which talks about hurricanes, tropical storms, and we are planning to have that in July as well. Also, a basic radar interpretation course. If you like to look at the radar images at home, maybe on your smartphone or on your computer, we can give you some tips as far as interpreting things like severe thunderstorms in particular, or even flash flooding. So working on that. And of course, as they happen, we will host more of these event reviews. So for now, the weather's quiet, but I'm sure it will get active once again. And of course, we really, really like your feedback. So please email comments to me. I'm Joe Deli Carpini, the Science and Operations Officer. You should have my email address on your webinar confirmation. Please give us feedback, what you like, what you don't like, maybe something you'd like to see. If we have a topic there that's not included, we're here, to provide you guys with information about the weather. We know we have a lot of weather fans out there, so this is a good opportunity for us to be able to teach you a little bit about the weather in southern New England. So please give us some suggestions. So for tonight, our presenters, we have Hayden Frank, who's one of our lead meteorologists, and Hayden's been with us, boy, since the early 2000s, I think. Hayden came to us from
hard to believe.
Yeah, came from us from the forecast office in Wichita, Kansas. So he's seen a lot of thunderstorms in the plains. He's originally from Philadelphia, so he's an East Coast boy, and he's been with us in Boston for a while. And let's see, the programs you lead, Hayden, if I can remember, the Doppler radar program, our marine program, fire weather. I don't know if I'm leaving anything else out, but so Hayden's one of the outreach too. Yeah, thank you. Hayden's one of the lead meteorologists, so he's one of 5 shift supervisors we have on duty. Then we have Rodney Chai, one of our meteorologists. He's been with us since October, and he likes all things winter weather, but we've kind of coerced him into liking severe weather, and he's taken a quick like of that as well. He came to us from the civilian side of the Navy out in Monterey, California, and this is his first job with the National Weather Service, so he's one of our rising stars. And then last but not least is Bill Latham, meteorologist. He is from Shrewsbury originally, and he came to us from the forecast office in Duluth, Minnesota. So he knows winter weather fairly well, but he's back home here in southern New England. And so with that, those are our presenters, and I believe, who's starting off? Is it Bill? Yeah.
Yep. Yeah,
okay.
That's me.
All right. So Bill, you may take it away.
All right. Well, good evening, everybody. So starting off here for this event, what we're going to take a look at on June 6th is this is from the Storm Prediction Center. And what this basically is showing you is basically the storm reports that we got across the lower 48 for June 6th. And just focusing on New England, as you can see in the blue there, is showing all the wind reports that that we received. But if you were to go to this page, you can see on the bottom left-hand side the different storm reports that we get and the number of reports for that specific threat that occurred. So tornado, wind, hail, and then they have a total of all the reports on the bottom. If you want to go to the next slide, Joe. So here is just a satellite loop. It's kind of a combination of the various different ways that we look at satellite. And not to go into all the details, but it's just a combination of the various ways that we look at satellite. And it's kind of highlighting in those warmer colors where we have thunderstorm activity going on. And another thing that to point out on this image as well is you can see these various little pluses and minuses, and all that is just showing the number of lightning strikes that are occurring from the thunderstorms that are going through. So taking a look here, here's the radar at 3 o'clock on Saturday, and as you can see, over central Massachusetts and into northeast Connecticut and northern Rhode Island, we have severe thunderstorm warnings that are in effect, which are indicated by the yellow box. And then one other thing to point out on the image here too, you can see those little thunderstorm symbols in the green that Joe's pointing out there, and those are just an indication of storm reports that we've gotten. And this is one of the software things that we look at to look at radar imagery. On this next image here is basically just showing as we go forward in time where the thunderstorm progressed from central Massachusetts, northeastern Connecticut, and northern Rhode Island into southeast Mass. And you can just see where that severe thunderstorm warning continues. And then the other boxes that weren't in the previous slide are showing you what we call special marine warnings, and that's just to give a heads up to those boaters out there to head for safe harbor when we're having a thunderstorm that could impact the boating industry. And this is an image taken by our fellow presenter here, Rodney, which is a picture of a shelf cloud at about a little before 4 o'clock, looking west from our office in Norton, Massachusetts. And then just going a little further into what happened during the event. So on the left-hand side is a picture from Mendon, Massachusetts, of a tree that was blown down onto a car, and then and on the right-hand side you can see another picture of tree damage where a tree was knocked down. And you'll see in the next couple of photos here that we have several lots of tree damage down. This is from Northbridge, Massachusetts. In both photos, the one on the left showing a tree that fell into a house and caused some roof damage. And then on the right, you can see the tree fell on a car in the middle of a roadway. And then again, more tree damage photos. The one on the left is from Needham, Massachusetts, and this is from the thunderstorms, which Hayden will talk about a little bit later, where we had thunderstorms that redeveloped later in the evening, causing some wind damage. And then on the right-hand side is from Whitensville, Massachusetts, which again, more tree damage. So during this event, we had a lot of wind that happened from the thunderstorms going through. Again, you kind of saw the wind damage reports. And this is just showing, some of those reports down on the ground. Now we're going to focus in on North Attleboro, where there was a little bit more significant wind damage. So on the left-hand side is the typical radar reflectivity, is what we call it, image that you would see on the Weather Channel or any TV channel that you're watching weather coverage from. And then on the right-hand side is what we call base velocity. But basically all that is just telling you what the radar's estimate of the wind speeds are at the level the radar is pointing. Now, if you take a look at noting the high wind speeds, which is depicted by the brighter green color over just to the northwest of Attleboro, you can see that what that's indicating is winds of roughly 60 to 70 miles per hour. And actually, that's one of the things that we look at when we're putting together those severe thunderstorm warnings, is we look at the velocities that are estimated by the radar to try to get an idea of what to put in on those wind speeds that we're thinking are happening from the thunderstorms as they're going through. And on the left-hand side they're a little bit offset, but on the left-hand side, you've got the radar reflectivity just going through time, and you can see how the severe thunderstorms progressed, or the warnings progressed as that line of thunderstorms moved eastward. And then also you can kind of see, it's a little harder to see those teal boxes showing where those special marine warnings are for the boaters. And then on the right-hand side is, again, the velocity information, and we're trying to look at getting a good estimate of the wind speeds as the storms are heading towards us. Now, one thing to kind of point out here, as you can see, as the storm heads at the radar, you kind of see that the greens turn to reds, and what the wind, when the radar is pointing out getting the velocity speeds, it's basically getting, the greens are showing the speeds that are coming in towards the radar, and the reds are indicative of wind speeds heading out away from the radar. And then this image that we're looking at on the right, or this loop that we're looking at on the right, is a classic signature for straight line wind damage. So just taking a look here, this is actually some photos that we received from North Attleboro, Massachusetts. And again, as I had said in the previous slides, we kind of the radar had an estimated wind speeds around 60 to 70 miles per hour, based on what we were looking at in the velocity data. And we actually, based on the damage photos that we received from North Attleboro, the radar actually had a pretty good indication of the wind speeds that were anticipated by the storm as it was going through. And so again, you could see, again, it's kind of a lot of the similar, lots of tree damage, trees knocked down. And again, at least in this instance, doesn't look like any trees hitting any houses or cars, or except maybe that a couple branches on that car in the bottom right-hand corner. And again, here's some more tree damage photos across North Attleboro. Lot of the same. So lots of wind damage associated with these thunderstorms as they went through. Now, I think it's with this slide that I switch it over to Rodney. Yeah,
thank you, Bill. So one of the common questions that we get from the public is, how do we distinguish between a damage from a microburst, which is a form of straight line wind, versus a tornado? And one of the things that we like to tell people is that when you look at the key here to determining between a tornadic damage versus a microburst damage is not so much in terms of the amount of damage, but the pattern of damage. And the case in point here would be, if you look at the tree damage, in the event of a microburst, you get large uprooted trees that are flattened in a similar direction, so they kind of like fan out. And versus in a tornado, you have uprooted trees as well, but they kind of crisscross each other, and that's because of the chaotic nature of a tornado. So they are not. So that's the key here, is the pattern of the damage that determines if it's going to be from a tornado or a microburst, or something less severe than that. So not so much in terms of the amount of damage. And we do our storm surveys. It could be in person. It could also be from an event a month ago. We actually had very good drone footage. Nowadays with technology, you can use the drone to have a panoramic view of the area of interest, and from looking down at the ground, you can see the pattern of damage very clearly. And we also rely a lot on storm reports as well, and we spend a lot of time to QC the storm reports, and we take reports from everyone. So, your reports are really important to help us during the storm survey and verification process. So just a quick review on the thunderstorm basics, and as Joe has talked about in the beginning, we're going to have severe weather 101 and 202 and all these classes that we're going to go into detail about if you're interested in severe weather. But this is a quick recap in the interest of time. There are really three main ingredients when we talk about what could produce thunderstorms, and you need moisture, lift, and instability and shear. So moisture, we tend to look at like low-level moisture, like as reflected in surface dew point. Dew points, we try to look for, say in the 60s, maybe mid to upper 60s, or you go out there and you feel it's really muggy outside. That's you have your moisture. Lift-wise, an example would be the cold front. That's why usually, when you look at radar, you see kind of a line of storms, kind of either out ahead or just along the cold front, because the cold front is a very good lifting mechanism. But also here in southern New England, especially coastal areas, we can also get sea breeze. So you can get fronts to form along with a sea breeze. And then thirdly, you have instability and shear. So instability, as we will talk about later, one of the parameters we look at is the convective available potential energy, or the K. And usually when you have good surface heating, you get a large amount of CAPE, and if you can break the cap, you can get thunderstorms to really fire up and in an explosive way. And shear is just the changing in wind direction and or speed with height. And we look. This is the 12 p.m. surface observations, and you can. The number in black is the surface temperature. The number in blue is the dew point temperature. You can see we have a widespread dew point in the mid 60s to lower 70s. So you really have a kind of almost like a tropical air mass out there. And then you can see towards the Connecticut River Valley, you have temperatures rising into the upper 80s and even low 90s. And so there's pretty good surface heating, thanks to a kind of like mostly clear skies that morning. And you can see the wind is from the southwest and southwest. So that's bringing in the higher dew points from the south. So, in a nutshell, we have the moisture because the dew points are as high as the upper 60s. And then do we have lift? Yes, if you look at the surface map, and this is produced by the Weather Prediction Center, and you can see that cold front kind of draped across the mid-Atlantic states, stretching into northern New England, and that cold front is the source of lifting mechanism that would provide the lift for the air particles to rise and generate showers and thunderstorms. And do we have instability? Yes. If you look at this map, this is the map showing the surface-based CAPE, or the SB CAPE. And generally, we look for values kind of like above 2,000, and the unit is joules per kilogram. And we can see a swath of CAPE that is over 2,500, and some 3,000. So there was a lot of surface heating that day, and which contributed to really a tremendous amount of CAPE. So we have all the ingredients checked off. And last but not least, we also have wind shear. In this case, you're looking at the bulk shear, effective bulk shear map. And we generally look for values above 40 knots. And in this map, you see there are areas above 50. And and even 60 knots to our north. So you have wind that is basically changing with direction and speed with height, and that kind of gives the storms more spin. And it usually, when we see there's a lot of bulk shear, the storms tend to be more long-lived and more explosive in nature when they do kind of get going. So now we look at model guidance, and I'll pass it back to Hayden.
Great. Well, thank you very much, Rodney. So one of the things we do as forecasters when you're trying to prepare a forecast 1, 2, 3 days out in the future is look at model data. And we have various computer models. There are countless numbers of weather models to look at, and they can all tell you slightly different things. Sometimes they can give you vastly different solutions. So one of the things we like to look at is a short range ensemble forecast. And basically, that's a bunch of weather models thrown together. So let's say you throw, say, 15 or 20 weather models together, you average them out, and you'll get a model consensus, and that is often your best forecast. Not always, but it'll get you in the ballpark. And leading up to this event, one of the things we look at, the short-range ensemble forecast, you can see in that red shading over southern New England, that was the highest probability of thunderstorm development in the Northeast. It doesn't mean you won't get thunderstorms outside that area, but that's giving an indication there to be very concerned for thunderstorms, especially in the Boston to Providence corridor there. And as we go on to the next slide, this is another computer model that we've basically used over the last 6 or 7 years. It's a relatively new model that runs every hour. And what you're looking at here is basically a radar simulation. So in this case, you'd be looking at what this weather model thinks the radar will look at 16 hours from now, where you see valid at 20Z Saturday. And in this case, you can see a line of showers and thunderstorms roughly along the Boston to Providence corridor. Now, again, the timing of this may vary a bit. The locations may vary, and since this is run every hour, you may see various solutions on each model run, but we're kind of looking for a general overview, what the models tend to be leaning to, so not jumping on a specific model run, but looking at where are they generally painting as the highest risk. And another thing we look at is something called a statistical severe convective risk assessment model. That's a lot of words there. But basically what that is a weather model that observes the current conditions and compares them to history's past and what type of weather you may get when you have certain ingredients in place. And in this case, it was looking at all the ingredients in place. Again, we look at, as Rodney was talking about, instability, wind shear, and that type of information. And you can see in the yellow shading there, that's where it's indicating the probability for severe wind in the next 4 hours, 3 to 7 p.m. Now, the probabilities may seem low to you, but they're within a 25 miles of a specific point. And keep in mind, severe weather isn't like a snowstorm where everyone usually gets, say 5, 6, 7 inches of snow. In this case, severe weather is often very localized, where it may be within a half mile of an area, and then outside that area, there's not much of anything. But that gives you an idea of where the highest probability of severe weather. And you can see all the models we've looked at so far are really pinning that I-95 corridor in that general area as the greatest risk. And another thing we like to look at, this is the HREF, and what this is just another high resolution ensemble forecast. So again, it's throwing a lot of different models into one model and averaging them out. And what do you know? This, in that green shading, this is the probability of the model in 4 hours, a 4-hour probability of thunder from the model. And notice it's highest right in southern New England, right in the Boston to Providence corridor. Again, it doesn't mean there can't be thunder outside that area, but that's giving you the highest risk. So you can really see how all these features were really lining up nicely, which gives forecasters confidence. When you see the solutions vary more, then we have less confidence. but this was a good case for that. And here's a last example. When we talk about thunderstorms, we talk about updraft. And what that means is the wind blowing up into a thunderstorm. And I used to do a lot of storm chasing when I was younger, and these thunderstorm updrafts can be so strong, if you're under one, it can be difficult to even open your car door. They can be in excess of 100 miles an hour. The strongest those winds are going up into the thunderstorm, the stronger storm you get, the greater risk of wind damage and hail. And again, look at where the highest probabilities of updrafts are within that layer, right again in southern New England. So we have all these features that are showing the same area, and that gives us confidence, and we can kind of communicate that information to you guys a lot better than when solutions are kind of varying. And I'm now going to turn it back over to Rodney, who's going to talk more about the messaging with this event.
Yeah, thank you, Hayden. In the forecasting enterprise, we talk a lot about collaboration, and us at the National Weather Service, we are one of the agencies in NOAA, which is the National Oceanic and Atmospheric Administration. And one of our core partners in, when you have severe weather outbreak is the Storm Prediction Center, and they are based in Norman, Oklahoma, and they basically they look at severe weather for the whole country, and we, in days leading up to a severe weather event, we would collaborate with the forecasters at SPC, and we share our ideas and thoughts, and kind of like fine tune our messaging. And if you go to their website, spc.noaa.gov, you can find out what areas across the country are likely going to experience some kind of severe weather. And for us, we collaborate with them, but we are ultimately responsible for issuing the watches and warnings, so be it severe thunderstorm warning or a tornado warning. But we do collaborate with SPC down in Norman, Oklahoma. So it's very much a team effort. And so just to understand the categories of severe thunderstorm risk categories, and and don't let the adjective kind of let your gut down. I mean, when you have like a slight risk day, it doesn't mean that it's you can take it lightly. Slight risk is actually, you can have it's more about the coverage of the severe storms. When you have a slight risk day, you can have severe storms, but they are more scattered in nature. And some of you may remember, on May 15, we actually have an enhanced risk that day, and it was also a kind of like a severe wind damage kind of event. But on that day, because of the environment, it was more favorable for more numerous severe storms. And then moderate and high risk, it's very rare in this area. It's more common out in the plains, in the tornado alley, and those are kind of you get the low-level jet from Gulf of Mexico, and you have out in the plains you can get pretty impressive storms. And like Hayden says, he used to storm chase, and he was based in Wichita, Kansas, and that is pretty much in the midst of the tornado alley. But in this case, Joe, if you were to go to the next slide. So initially we had a marginal severe risk, and here I want to point out to you the importance of collaboration. SPC, because they're based in Norman, Oklahoma, I mean, they are a team of experts in severe weather, but sometimes, because they have to kind of, they only have so many people, but then they have to take care of severe storm coverage in the whole country. So, sometimes there might be a little bit kind of like an oversight, or like and that's when the local weather forecast office like us comes in. We use our knowledge and local knowledge to kind of collaborate with them and kind of convince them that maybe we could consider raising the risk level. And in this case, we got them to initially raise from general thunderstorms to marginal severe risk. And when that happened, we kind of we send a DSS email, a decision support service email to our partners, be it emergency managers or even local government officials. And this was the email sent out by Hayden and Bryce, which is one of our meteorologists as well, and just kind of give a heads up to the local officials, that there's a marginal severe risk. And we did actually, SPC actually did upgrade it to slight risk that right before the storms. So it was an event where the severe threat came into focus kind of relatively late. So the SPC, one of the things that they are responsible for is to issue the mesoscale discussion, and abbreviated as MCD, and they highlighted the area not just for southern New England but also into Maine and New Hampshire, and basically this mesoscale discussion is kind of like a heads up. If you go to their website, you see that they highlighted this area, and this is the area where there's a greater chance of seeing severe weather later that afternoon. And eventually, about 1.5 hours after they issued the mesoscale discussion, and upon further collaboration with local weather forecast officers, and in this case, you're talking about the Boston office, the Gray, Maine office as well. And so this is a general picture of where the severe thunderstorm watch was issued. And a key difference between watch and warning, like I like to tell people, is that a watch is when you have the ingredients are there for the potential development of severe weather. When you have a warning, it means that the severe weather is happening, either based on spotter reports or radar indication, and the time for preparation is over. You need to take immediate action to take shelter or safeguard your life and property. And in this case, the main threat would be the severe wind, and we will cover this in the Severe Weather 101, but the severe criteria for wind is 58 miles per hour, or when you have confirmed tree damage or down power lines. And for hail, it would be quarter-size hail or 1-inch hail, or you can, a sighting of a tornado. But in this case, it's wind, straight line wind up to 70 miles per hour. So I'm going to pass it back to Hayden, who's going to talk about the second round of storms in the evening.
All right. Thank you, Rodney. As we went over the model section, the models did a really good job with this event, although they did struggle with this second round of thunderstorms. But I got to give Rodney here a lot of credit. When I came in for my mid-shift, he was ready for it because the cold front hadn't crossed the region yet, which was key here. And these are some pictures that, as a result of that second round of thunderstorms, roughly after 8 p.m. that evening, and you can see Methuen and Stowe, a lot of tree damage from strong straight line wind gusts. And as we go forward here, we look at the radar. Because the stuff that came through earlier in the day had moved offshore, there was enough time and enough moisture left over before the cold front crossed for one last round of thunderstorms. And you actually see two thunderstorms developing, one just east of Worcester, and the main one, which was the one north of that, just south of Leominster. That would become the main severe thunderstorm that went all the way towards the Boston area and you will see a loop of that right here. And you can see the yellow indicated the severe thunderstorm warnings that were issued. And again, the left image is a look at where the heavy rain is with the thunderstorm. The right image is a sample of the winds within the storm. And notice in that box there, you actually see that color turn blue. That's an indication of 60+ mile/hour winds that the radar is seeing. Sometimes the radar doesn't see it depending on the vantage point, but in this case, it did see it for a time. And actually, the winds were actually more widespread. So again, it gave you an idea of where the wind was as those storms raced towards the Boston area and weekend as they approached Quincy. But you can really see the velocity data, which is what we issued the warnings based on, because we could see the potential there for damaging wind gusts. And we all want to thank you for attending the June 6th review. And I'm going to turn it back over to Joe, and we're going to have some time for any questions you guys might have. But we really want to thank you for attending.
All right, thanks Hayden and Rodney and Bill, and we're going to go through our questions right now, and we should have plenty of time to answer these. So let's see, going through the list. William says, thanks for retweeting my time lapse a few days ago. I'm the person who recorded and posted the footage. Yeah, so one thing I want to encourage is when there are storms around, obviously if you can do it safely, if you want to send us pictures or video of what you're observing, you can always tag us on social media. We'll see those right away, and certainly they help us, get a better understanding of what's happening at the time. And then also for these post-event reviews, it can be very useful. So we encourage you to submit your reports. Of course, just make sure things are safe. Question from David: does the radar measure circumferential wind speeds or only radial? Hayden, you're the radar guy. Let's let you answer that one.
Well, it's generally it's measuring radial speeds, but what it's doing is it's going up in different elevation angles. So depending on where you are within the radar, if you're say 10 miles away from the radar, you're seeing it at a much lower level than if you're out in the Connecticut River Valley. So there's a lot of different things that go into it when we're kind of reviewing the winds within the storm. And if the storm is going towards the radar, then it tends to pick up the winds quite well. If it's not going towards the radar, the estimates are often well underdone. So there's a lot of things you have to take into consideration, especially the environment that you're dealing with.
Okay, and let's see, here's another radar one for you, Hayden, from John. Can the Doppler velocity profile be used to visualize the updraft feeding the storm?
Yes, it certainly can. One of the things you'll often see in what we call supercell thunderstorms, what you get a lot out in the plains, is because the wind fields are much stronger as you get up in the atmosphere, there'll be a tilt to the storm. So if you're looking at those higher elevation angles that are looking higher up into the sky, obviously, you'll see stronger reflectivity, and if you go down into the lower levels, it's lagging behind. So that tilt is what makes supercells. If you have weaker wind fields, you kind of tend to get more of a straight up and down. But when you see like strong reflectivity at higher elevation angles, but don't see anything below, it could be like what we call a bounded weak echo region, or a weak echo region down low, where the higher cores are aloft, but they haven't reached the surface yet because of those stronger winds aloft.
Okay, and John and David, you had both radar questions, so you may want to stay tuned for our Radar Interpretation 101. That'll be a little bit later this summer. We could actually go into some of that and show you some of the things that we use to kind of better understand what's going on within the storm. There's other things we can look at too, so we can hit on some of those. Let's see, a question from Joe. I believe DCAPE was at 1,100 joules per kilogram that afternoon, and I believe you're correct, Joe. So a little technical, but DCAPE is downdraft cape. So it's that energy that Rodney was talking about, the buoyancy in the storm. And DCAPE is downdraft cape. So essentially the higher the number, the greater potential you have for a strong downdraft, which is that rushing out of cold air from the thunderstorm, which produces the damage. So I believe usually around 800, 700, 800 or greater starts to get us a little concerned. And yeah, the downdraft cape that afternoon was certainly high. So that tells us there's a good potential for wind damage. Fred, my friend Fred, says, strange thunderstorms at night. Not a twig on my lawn, but huge tree and wire damage 4 houses away from me. And yep, that's what happens. It's thunderstorm damage is always highly localized. So, in some cases you can have damage, a few blocks away and nothing where you are. And in some cases it's more widespread damage, just depends on the storm, the type of storm. Like the May 15th event certainly was more widespread damage up in the Westford and Pepperell area. But yeah, in this case, it was definitely fairly localized. Let's see. William has a question. How tall were the thunderstorms on June 6th? And Hayden or Rodney, I'll let you answer that because you worked it, I believe. Do you remember by any chance?
I don't know the specific height. I mean, there's times where you can get tops 50, 60,000 feet. In this case, most of it, these weren't those type of storms. I again couldn't give you a specific number, but what made this more of a wind event was that we had very strong winds in, say, around 20 to 30,000 feet, and they were able to brought down by the thunderstorms. The bigger severe weather event we had on May 15th had much higher cloud tops. I can't give you a number on that, but that's why that was more of a significant event. That does have a significant factor in the amount of severe weather and the magnitude of it as well. But this again was a modest severe weather event, and there was a fair amount of wind damage. It was somewhat more localized than May 15th, but still significant for some areas.
Okay. Next from Josh. You mentioned earlier that the models struggled to predict the second round of storms. What does it take to improve the modeling for future thunderstorms? Thanks and love interacting with the IndyBus Boston team. Thanks, Josh. Hayden, do you want to handle that one, or would you like me to?
Yeah, sure.
Okay.
Basically how it works when you're forecasting thunderstorms, if the model has the thunderstorms moving through an hour or so earlier or later, that makes a big difference on how well the atmosphere can recover with remaining daylight, and can have a significant impact on whether there is a second round. One thing I've noticed is this isn't uncommon where you get like one main round, and if it comes through early enough, if most of it's done by say 4 or 5, especially this time of year where you still have the sun out, pretty much past 8, the models often miss that second pulse, especially if a cold front hasn't crossed the region yet. So the models are getting a lot better. I mean, compared to where we were even 10 years ago, we didn't have all these high resolution models to look at. But thunderstorms are such small scale in certain ways. One of the folks were asking about, well, 4 houses down, it was a big difference, and that's how difficult it is. Imagine for a model trying to simulate that is extremely difficult. But they're getting a lot better.
Okay, another question from John. It appeared as though the storms broke up as they crossed northeast Mass. If I'm remembering correctly, what were the dynamics in play that caused this?
Yeah, that's usually a common occurrence, especially early in the season. We tend to have southwest winds, and usually as you get near and especially southeast of Boston or Providence, you're entering more of a marine layer. Even in obviously northeast Mass, there was a portion of that north of Boston that is more exposed to the ocean on a southwest flow. So if the ocean's still in the 50s, that's not really good for thunderstorm development. Usually causes them to weaken. So as you get later in the season, especially say late July into August, that becomes much less of a factor as the ocean starts to warm up.
Okay. Let's see. Next one from Scott. How or did the terrain impact the damage field?
I guess I could take that one. really there wasn't any evidence of the terrain impacting the damage. Now, to be honest, probably on a small scale, there always are terrain impacts. But they're so difficult to measure. Going up, say 200 feet here or down 75 feet there. There's so many, not even what we call micro scale impacts that really are. We're still decades away from being able to assess those type of impacts on thunderstorms. But that type of thing is likely in play, but it's very hard to. Unless we have a real significant event, and really hard to highlight that.
Okay. Question from Peter. Does the National Weather Service use analogs for severe weather events, much like for winter storms? I can give you a break, Hayden. Yeah,
Okay.
actually we do. There are several, we go back. There's some websites out there too. I know St. Louis University is very big. It's called the CIPS analog, CIPS, if you want to Google it. And they're analogs for severe weather, winter weather. So we'll use that quite a bit. And maybe we're using that a few days out, not necessarily the day of the event, but kind of gets us in the ballpark with what we can expect. What kind of storms are we looking at? Are we looking at more of a wind threat, maybe a flash flood threat or a tornado threat? So they can come in useful. So it's more kind of on a general scale. It's not going to tell you exactly what's going to happen. But yes, we do use analogs in the forecast process. Probably a little heavier for winter storms than we do severe weather, but that's one of the tools, kind of in our belt that we can use. Question from Michael: were you surprised by the severity of the second storm? Did it cause more damage than the first storm? And Hayden, you're the second storm guy, so I'm going to make you do this one.
Yeah, no problem. So the first storm did end up that went through the Attleboro area. That did cause more damage. But the second thunderstorm still caused a fair amount of wind damage. Was it surprising the amount of wind damage? I have to say I was probably a little surprised. Not that the storm became severe, but that it caused that much damage. But there were some parameters that we were looking at that did favor that. The cold front was not through us yet. We had high instability, and as Rodney had talked about, we still had 50 to 60 knots of effective bulk shear. That's the wind changing speeds with height, and that's very significant. So I have to say I was a little surprised, but not shocked. It wasn't something that couldn't happen given the conditions.
Okay. Next question from Patricia. I live on the east edge of the Connecticut River Valley. This event gave us barely any rain, but generally when storms do pass through east to west, they appear to weaken as they're over us and then re-strengthen as soon as they pass, even though there are hills and mountains. Why is that?
I guess I could take a stab at this one.
Sure, I can help you out too. Go ahead.
Yeah, there's been a lot of studies actually done, especially over the Connecticut River Valley. One is that as you get into the valley area, there tends to be, because of that change in height, that lowering of height, more of a alteration in the wind direction, which actually can lead to tornadoes. Obviously not like the Midwest, but there can be what we call a very mini, tornado zone within southern New England. Going, further in specific areas, it's hard to, a mile here, 2 miles there. But in that valley area, as you're coming out of the hills and down into the Connecticut Valley, there is a transition going on. A tendency initially maybe to weaken, but then as the winds start going into the storm, a strengthening. So that doesn't surprise me, but trying to pin down where exactly that happens it's going to depend a lot on the exact environment we're dealing with, and your exact location too. And Joe, feel free to add anything.
Yeah. I mean, the storms are coming, out of the Berkshires essentially. So don't forget the air is coming down out of the hills. It's sinking. which you're kind of losing a little bit of the lift that we talked about and getting that air up there. So that could cause them to weaken, and then they get to the other side of the valley, and guess what? The air is going up again, so it's being lifted, and there can be some re-strengthening. So they may have something to do with it too. But these are such small scale things going on. It can be difficult for us to really detect these or anticipate that that's going to happen. So yeah, kind of that's probably my guess as to what's going on. You're just losing a little bit of that lift that's helping keep the storms kind of going. It's not killing them, but it's weakening them probably just enough, and then strengthening again as they hit the hills to your east. So that is all the questions I have in the chat box. So thank you everybody for submitting your questions. Again, just a reminder, we are recording this. It will be on our YouTube video page within a couple of days. All of our webinars will be recorded and posted on our YouTube page. We're trying to make better use of YouTube, which if you go to our page, you probably won't see anything for a couple of years, except for recently here. So you can always go back and take a look. If you can't make a webinar, they will all be posted there. And just a reminder, our next webinar will be next Tuesday, June 23rd at 7, and that will be our Weather 101 course. So feel free to sign up on our website. This will be more or less a basic weather course. We're not going to get too technical on this one, but just some basic meteorology concepts just to help you learn a little bit more about the weather. And again, please, provide feedback to me. I really like hearing from everybody. Future topics, we would love some suggestions. We're trying to think of some, among our team here. But anything you want to learn about the weather here in southern New England, please let us know. Also, if, feel free to send us some feedback. Was this too technical? Was it too simple? We're trying to strike that balance so we can get most people understanding what we're talking about without getting too scientific or too much lingo. So please, feel free to give us your feedback. That's what we're here for, is to serve you and serve our community. So we have a lot of folks here who love doing what we do, and we'd like to share our love of weather with all of you. So thanks again, and stay safe. Have a good night, and we will see everybody on Tuesday. Thanks again.
Great.